Welcome to Geometry Unit 8 skill video for skill number 57. I can use trigonometric ratios and their inverses to solve a triangle. Alright, we'll begin our notes on page 57A, where we are first introduced to our three trigonometric ratios. Our first three ratios are sine of A, and that is the opposite leg over the hypotenuse. Cosine of A, which is the adjacent leg over the hypotenuse, and then tangent A, which is the opposite over adjacent. So oftentimes what we'll do is we'll say sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. Very frequently you'll hear people say so, ka, toa as an acronym or learning mnemonic to help remember these things. And what exactly does this mean? It means if I'm looking at sine A or angle A, sine of that angle is equal to the opposite. So the opposite of A is 3, opposite leg, over the hypotenuse, which is 5. So sine of A is opposite over hypotenuse, 3 over 5, or 0.6. And this would be true for all right triangles. So that's the purpose of these trig ratios, is they help us solve right triangles, find missing information. Cosine of angle A is the adjacent leg, the leg that touches angle A. And we place that over the hypotenuse. So adjacent over hypotenuse. Adjacent is 4, hypotenuse is 5. Which gives us 4/5. Cosine A is 4/5, or 0.8. And then tangent A is the opposite over adjacent. So for A, the opposite is 3, the adjacent is 4, so 3/4 is tangent A. If we scroll down further, I've given another example for angle B. So we can find sine, cosine, and tangent of any angle. For angle B, we know that sine is opposite over hypotenuse, so the opposite of B is 4, and the hypotenuse is 5, so sine B is 4/5. Cosine B is adjacent, the leg that touches B, over hypotenuse, so 3/5, or 0.6. And then finally, tangent B is opposite, so opposite B is 4 over adjacent, which is 3. We should be able to do this for any right triangle. Find the fractional form or the decimal form. And shortly here we'll get into the benefit of knowing these ratios. On page 57B, we are given our first example where we have a triangle, and that triangle is triangle ABC with angle B being 20 degrees. And they ask us to find the length of AB, the hypotenuse, find the length of BC, the leg, and the measure of angle A. So I'm going to start with finding the side lengths, and the first side length that we want to find is side length AB. We notice that AB is the hypotenuse, so chances are we're going to be using sine or cosine. And from angle B, we have the opposite side, and we're looking for the hypotenuse. And if we recall our SOHCAHTOA, we know that sine is the one that includes opposite over hypotenuse. So sine of angle B is opposite over hypotenuse. So the opposite of B is 7.3, and the hypotenuse is the length we are looking for. Using algebra, we can write this out as AB times sine 20 equals 7.3, and then finally divide both sides by sine 20, and we get the exact answer. But if we want to approximate this answer, we can type it into a calculator, making sure our calculator is in degree mode, and we arrive at a length of 21.34, approximately. If we wanted to find BC, we now have the opposite side, and we are looking for the adjacent. So tangent uses opposite over adjacent. Tangent of B is opposite over adjacent, so our opposite is 7.3. Our adjacent is what we're looking for. And this solves out very similarly to the top one, except we're using tangent instead. And we find that the adjacent side, the leg that touches the angle, is a measure of 20.06. 20.06. And our hypotenuse was 21.34. If we wanted to, we could check this using the Pythagorean theorem and find that 7.3 squared, so leg squared plus other leg squared, is approximately hypotenuse squared. And that works out. The discrepancy between the actual values is based in our rounding of our answers. Finding the angle is much easier. We know there's 180 degrees in an angle, so we add the three angles together, our unknown plus 20 plus 90, and we find that our unknown is 70 degrees. Example 2 gives us triangle ABC, and they actually give us the three side lengths of 8, 15, and 17. So if we wanted to find our sine of any one of the angles, actually we know that C is a right angle. If we wanted to find sine of A, we just take a look at angle A, and opposite for A is 15, and the hypotenuse is 17. So sine of A is 15 over 17. If we wanted to find cosine of A, cosine is, let's see, we have so, ka, toa. So cosine is adjacent over hypotenuse. So the adjacent side for A is 8, and the hypotenuse is 17ths. So cosine A is 8/17. And then tangent A is opposite of A, 15, over adjacent to A, which is 8. If we do the same thing for B, sine is opposite over hypotenuse, so 8/17. Cosine is adjacent over hypotenuse, so 15 over 17. And then tangent for angle B is opposite over adjacent. Opposite, adjacent. On the second half of page 57C, I've worked out sine, cosine, and tangent for our special angles, the 45-degree triangle and then the 30, 60, 90 triangle. I won't walk you through it, but I advise you take a look at this and see various things like cosine of 30 is opposite over hypotenuse, 1 over 2. And just understand these. These are very commonly used ratios. When we need to find angles, we can use inverses of trig ratios. And the trig ratios we know are sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. So in the diagram here, if I'm looking at sine of A, I'm going to go for the opposite over the hypotenuse. So the opposite is 15, the hypotenuse is 17. So we're able to say sine of A is equal to 15/17. Well, what if we wanted to find out the angle? What is angle A? Is it 10 degrees? Is it 30 degrees? what is the angle measure? And what we can do is we can actually take the inverse sign. So we take angle A and leave it alone on the left-hand side, and we take the inverse sine of 15/17. And provided our calculator is still in degrees mode, we will get the measure of angle A. So in this particular triangle, angle A is approximately 61 degrees. And I've shown a check here using the cosine inverse, because cosine of A is going to be adjacent over hypotenuse, or 8/17. And if we do cosine inverse of 8/17, we find that A is also, again, 61.93. Excellent, it checks out. And we do a double check just to see the tangent inverse works the same as well. Tangent of A is going to be opposite over adjacent, so 15/8. The inverse tangent of 15/8 also gives us 61.93. So all three trig ratios show us what angle A is. I wrote down what exactly is going on with the inverse trig functions down here. If sine of A is x, then inverse sine of x will be the measure of angle A. All of this builds to solving a right triangle, which we'll look at on the final page of our notes. All right, for solving a right triangle, if we have three pieces of information about a triangle, then we can find the other three pieces. So in the example here, what I've got is I have a right triangle and I know two angles and a side. So I would be able to, using what we've just learned, figure out the other two sides and the third angle. So that's what's called solve the right triangle. It means find all side lengths of the triangle and all angles of the triangle. So we're going to start by finding the length of our hypotenuse, which is AB. Actually, it looks like I solved for the angle first. Very easily, we could solve for the angle. 90 plus 28 plus angle A is 180 degrees. So we found angle A is 62 degrees, because 62 plus 28 plus 90 is 180. So we have our three angles, and now we're going to get the three sides. They give us one side, and let's look for the hypotenuse first. So I'm going to use my known angle of 28 degrees, and I'll say the known side is the opposite of 28 degrees, and I'm looking for the hypotenuse. So I recall from SOHCAHTOA that the one that includes opposite and hypotenuse is sine. So sine of 28 degrees is going to be opposite over hypotenuse. Sine of 28 is 4.3 over AB, which is the hypotenuse. Using algebra, I solve out AB to be approximately 9.16 units in length. I use the same method for finding BC, which is the other leg, except this time I need tangent because I've got the opposite and I'm looking for adjacent. So tangent of 28 is 4.3 divided by BC. And I solve BC to be approximately 8.9. Finally, I check it using Pythagorean theorem. 4.3 squared plus 8.09 squared should be approximately 9.16 squared. And it checks out with only minor discrepancy due to rounding. For the skill test on this, we'll be actually heavily focusing on solving right triangles. So I may give you 2 or 3 right triangles and say solve these triangles. All right, the key ideas and concepts for this skill really boil down to solving right triangles. If we're able to solve right triangles in a variety of fashions, we pretty much have been able to master all aspects of this skill. That means we should know our trig ratios. We should know SOHCAHTOA, which is the acronym we use for our trig ratios. We should know how to find inverses of trig ratios, which we use to find angle measures. And we should also be able to use the Pythagorean theorem, because that's an excellent way to check. And finally, this is just a strong reminder that there's 180 degrees in a triangle. SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And the Pythagorean theorem, a squared plus b squared equals c squared, where c is the length of the hypotenuse.